Were you surprised to see how the resistance R affects the reading of galvanometer? What is the principle on which this JEE question should be solved? In around 3 to 4 minutes, you will feel confident in solving this and many similar JEE numericals. So watch the video till the end. Welcome to the 10th video of the current electricity numerical series. First, simplify the circuit. The galvanometer can be treated as a 30 ohm resistor because its coil resistance is given as 30 ohm. Now, the idea becomes very simple. Out of the total 3 ampere current, we want only 20 milliampere to pass through the galvanometer. Think of it like traffic on a narrow bridge. The narrow bridge is weak and can handle only a few vehicles safely. So engineers build a wide parallel bridge beside it. Naturally, most traffic uses the wider bridge, while only a small amount goes through the narrow one. Exactly the same thing happens here. The galvanometer is the narrow bridge. The shunt resistance is the wide bridge connected in parallel. Because the shunt has very low resistance, most of the current flows through it. Only a small, safe current passes through the galvanometer. So converting a galvanometer into an ammeter simply means protecting it by diverting most of the current through a low resistance parallel path. Now come back to the actual circuit. The 3 ampere current reaches the junction and splits into 2 branches. Here, we apply Kirchhoff's current law. According to KCL, total current entering a junction equals total current leaving it. So the incoming current is 3 ampere. Out of this, only 20 milliampere flows through the galvanometer. The remaining current, called I1, flows through the shunt branch. Now convert 20 milliampere into ampere. 20 milliampere means 0.02 ampere. So, 3 ampere equals 0.02 ampere plus I1. Therefore, I1 equals 3 minus 0.02. That gives 2.98 ampere. This tells us something very important. Almost the entire current, 2.98 ampere, bypasses the galvanometer through the shunt branch. Only a tiny current of 0.02 ampere passes safely through the galvanometer. That is why the shunt resistance must be very small. Lower resistance attracts larger current. Now focus on the galvanometer branch and the shunt branch. They are connected in parallel. And in a parallel connection, voltage across both branches is always the same. The galvanometer current is 0.02 ampere, and its resistance is 30 ohm. Using Ohm's law, voltage equals current into resistance. So, 0.02 into 30 gives 0.6 volt. That means the voltage across the shunt branch is also 0.6 volt. Now apply Ohm's law to the shunt resistor. Voltage is 0.6 volt, and current is 2.98 ampere. So resistance equals voltage divided by current. This gives approximately 0.201 ohm. The question says the shunt resistance is 30 upon X ohm. So, 30 upon X equals 0.201. Solving this gives X approximately equal to 149. So the final answer is X equals 149. The beautiful thing about this question was, we solved the entire problem using only 2 ideas: Kirchhoff's current law at the junction and equal voltage across parallel branches. Once these 2 concepts become clear in your mind, galvanometer conversion questions become extremely easy. Thank you for watching till the end. In the next video, we'll solve another interesting numerical from JEE Mains as shown here. If you found this video helpful, make sure to like the video, share it with your friends, and subscribe to the channel for more current electricity numericals. And do comment below if there's a particular problem you want me to solve next. See you in the next video.